Hey guys, today we're going to walk you through some of these simple machines practice problems. In the previous video, we outlined some of the ways that you can calculate simple machines, that you can have mechanical advantage. We talked about both ideal mechanical advantage and also actual mechanical advantage. Remember that ideal mechanical advantage involves distances, and actual mechanical advantage involves forces. So if I take a look here at our problem with the lever, notice how it says a first-class lever in static equilibrium has a 50-pound resistance force and a 15-pound effort force. The lever's effort force is located 4 feet from the fulcrum. So static equilibrium just means that the whole system is stationary or not moving. So sketch and annotate the lever system described above. So I went ahead and put in a lever, all right, with my fulcrum, and then with the two things attached to either side of it. So we're going to put in our effort and resistance forces as well as our distances. Okay, so the first thing that we're given here is FR, right, which is 50 pounds, okay? Then we're given FE, so I can go up and I can insert a text box, all right? That's way too big, but we'll come over here and we'll use that. So FE equals 15 pounds, and we'll put that on the other side of the lever. Okay, so we have FR 50 pounds, FE 15 pounds, and then lastly we need an effort distance, or DE. Okay, so we'll come over here. Whoops, that didn't do what I wanted to. Let's see. Okay. Alright, so if I come over here, okay, my DE equals 4 feet. Alright, so that's the setup for my sketch. Alright, FR equals 50 pounds, DE equals 4 feet, and FE equals 15 pounds. Alright, so jump down to number 2. Says what is the actual mechanical advantage of the system? So they want a formula. So AMA equals, remember, AMA free, so FR divided by FE. Okay, so there's AMA free. Alright, substitute and solve. So we don't know what AMA is. That's what we're trying to find. We're going to put in 50 pounds for FR and 15 pounds for FE. So then I come to my final answer, come over to my calculator, which is off screen. 50 divided by 15 gives me a final answer of 3.33. Now, there are no units associated with the mechanical advantage because it's ultimately just a ratio. Alright, so we can jump down now to using static equilibrium calculations, calculate the length from the fulcrum to the resistance force. So this is a simple kind of cross-multiply equation. Remember, if you have static equilibrium, everything is still. So the combination of forces and distances, right, needs to equal 0, right, or cancel each other out. So the formula looks like this. FE times DE equals FR times dr. Okay, so we'll come over here to substitute and solve. So if I scroll up, Okay, we have an FE of 15 pounds, right? We have a DE of 4 feet, and we have an FR of 50 pounds, and we have a DR we don't know, so that's what we're trying to solve for. So basic algebra tells us that we're going to do 15 times 4, which is 60, okay, and then divide out 50. So you're looking at 60 divided by 50. So your final answer here for DR equals 1.2, and it's a distance, so we'll enter that into feet. Okay. So let's move on to our next situation. Okay, so we have our next situation set up with a wheelbarrow. Now, a wheelbarrow is an example of a second-class lever. So here with the second-class lever, you have a fulcrum at one end, you have the resistance force in the middle, or the load, and you have the effort force over here at the very end. So now let's plug in what we know. Okay, 200-pound load, that is going to be our resistance force. So that's FR, and that equals 200 pounds. Okay, our FE, then our effort force is over here. We don't know what that is. Okay, and then we have a resistance distance, which is from the load to the fulcrum. Okay, so the resistance distance, okay, I'm just going to put this over here, dr equals 2 feet, okay, and then the effort distance, or DE, equals 5 feet. So there's our situation with the second class lever. Okay, so it says illustrate, annotate the lever system described above. Your situation should look something like this. Okay, so we're going to jump down to number 5. What's the ideal mechanical advantage of the system? Okay, that is going to be IMA. So IMA equals DE effort distance divided by DR, which is resistance distance. Okay, I'm a deer is kind of the slogan or the saying for that. So substitute and solve. We're solving for IMA. So we're going to have IMA equals 5 feet, because that's our effort distance, divided by 2 feet, which is our resistance distance. So IMA equals 5 divided by 2, so that's 2.5. Again, IMA is a ratio, so it does not have a unit. Okay? Then it asks you for static equilibrium calculations. So calculate the effort force needed to overcome the resistance force. And it'll go on from there. So basically, we're working through at least one problem of all of the different kinds of simple machines. Okay? So I will leave you to complete the rest on your own. And always, if you have questions, shoot me an email.